Hello! So today we're going to be looking at the structure of the atom. Please make sure all of your tabs on the computer are closed, your phone is switched off or set to silent so that it does not distract you, and you can pay full attention to this video. Once you have watched the video, please do have a go at going through the questions on the worksheet. We're going to start off having a look at our key words for this unit. So an atom, which is the smallest part of an element itself is a substance that cannot be broken down into anything smaller. It can only be broken down into atoms of the same type. We can join atoms together, and if we get two or more atoms joined together by a chemical bond, that forms a molecule. Now, if we have two or more different atoms joined together, that makes a compound. So our key difference here, if they are different atoms, they will be a compound as well as being a molecule. Now, inside our atoms, we have protons, neutrons, and electrons. Protons and neutrons are inside the nucleus, and they have a relative mass of 1. A proton has a charge of +1, a neutron has a charge of 0, or it is neutral. Now our electrons, they orbit the nucleus, so they go around the centre of the atom, and they have a mass of 0 and a charge of -1. This is where atoms are able to have an overall neutral charge, because they have the same number of protons and electrons, so the charges cancel out. We then have two key terms at the bottom that people often get confused about. We have isotope and ion. Now, an isotope is a version of an atom that has a different number of neutrons. Isotopes are often radioactive as well. If you think about The Simpsons, their sports teams are called the Isotopes. They've got their big nuclear power station there as well, which uses radioactive material. And an ion is an atom that has lost or gained electrons. If it's lost or gained electrons, it will change the charge of the atom, which is how we can get onto ionic bonding. Now you may be sitting there going, that's all well and good, Mr. Lewis, but how do we know how many protons, neutrons, and electrons are in an atom? And the answer all lies on the periodic table. The periodic table has a list of all 118 elements, about 100 of which occur naturally. The rest of them can be made in a laboratory. And the periodic table lets us know how many protons, neutrons, and electrons are in an atom. We're going to zoom in. We're going to have a closer look at sodium. So we have sodium here. We've got the chemical symbol for sodium, Na, the name, sodium, and two numbers on here, 11 and 23. Now the number 11, in this case, is at the bottom, not always. This is our atomic number. And this tells us the number of protons. Now you might be thinking back and going, I remember earlier that our number of electrons and our number of protons are the same, so that an atom has a neutral charge. And you're right. The atomic number for when it is an atom also tells us the number of electrons. So it is the number of electrons when it is an atom. Now this number at the top is 23, is our relative atomic mass. It is how much it weighs in relation to a carbon atom. So our relative atomic mass, and it is the sum of our protons plus our neutrons. So if we wanted to find out the number of neutrons within an atom, we would have to do a tiny bit of maths. So for our number of neutrons, we would have to do our relative atomic mass, take away our atomic number. Now for this case, our relative atomic mass is 23, and our atomic number is 11. So we would do 23 minus 11, and that would give us 12. So we can then say for sodium, we have 11 protons. We have 12 neutrons. Let's put that number from there. And we have 11 electrons, because our electrons and protons are equal, so the charges cancel each other out. And remember as well, our neutrons have no charge. Now I can hear some of you asking, well, how do we know where we put all the electrons? Because I know that the protons and neutrons are in the nucleus, but where do my electrons go? And my electrons go in shells. And we put them in a certain order. In the first shell, we can fill up with 2 electrons. In the second shell, we can get a total of 8 electrons in there. And in our third shell, we can get another 8 electrons. And that's all we need to know for GCSE. So if we have a look at sodium, and we'll draw sodium out, you might remember that sodium has a total of 11 electrons we need to draw. So, to start off with, we draw or write a chemical symbol in the middle to represent our nucleus. And we need to do a total of 11 electrons. And I'm looking at going, in my first shell, I can fit 2 electrons. So I do 1, 2. I've got 11 to draw. I've drawn 2. 11 take away 2 is 9. I've got 9 left. So I'm going to do another shell. And I'm going to go, I'll just draw all 9 in here. So 1, 2, 3, 4, 5, 6, 7, 8. And I can hear some of you shouting, Mr. Lewis, stop doing that. You can only get 8 electrons in your second shell. We need to add a third shell to make our next electron. So we'll draw it in there. Now, very helpfully, when we look at our periodic table, sodium is in group 1. So it has 1 electron in its outer shell. It's the same for all of the group 1 elements. They all have 1 electron in their outer shell. Our group 2 atoms or elements have 2 electrons in their outer shell. And it's the same for all of the groups. The number of the group tells us how many electrons are in their outer shell. For example, group 7 elements have 7 electrons in their outer shell. Now, atoms generally don't like not having a full outer shell. They would much rather have a full shell than have 1 spare electron or 2 or 3. So they will either lose or gain electrons to get a full shell. In the case of sodium, it's got 1 electron there. To have this shell being full, it would need to gain another 7 electrons. It's definitely a lot easier, I think, to lose 1 electron than it is to gain 7. So it will lose that electron. It's lost that electron. We now have a full shell around it. And to show that we've lost that electron, we're going to draw some brackets around it, and we're going to need to put a charge on it as well. Now you might remember that sodium had, at the start, we had 11 protons and 11 electrons, and the charges cancelled out. We now have 11 protons, still we haven't done anything to our protons, but we only have 10 electrons. We've lost an electron. We now have an overall positive charge of +1. So we're going to write a plus up there to show that we have now got an overall positive charge and we have become an ion. This is something that has now lost or gained electrons. The final thing we're going to look at are isotopes. So isotopes are a version of an atom that has a different number of neutrons. Now, this generally makes it radioactive because it is unstable and likely to decay. And we can look at what that does to our atoms and their relative masses. So I've got symbols for 3 different isotopes of carbon. We've got carbon 12, carbon 14, and carbon 16. Notice that the atomic number at the bottom has stayed the same, but our mass number has differed. So if we were to work out the number of protons and neutrons on each one, we could go for this first one. We have 6 protons, and 12 minus 6 to find our neutrons is 6. For this next one, we have 6 protons still. We now have a different number of neutrons. We've got 14 minus 6, which is 8. And finally, we have on our final one, we still have 6 protons. However, we have 16 protons and neutrons. This gives us a neutron number of 16 minus 6, which is 10. So that is a whistle-stop tour on atomic structure. I hope you have found it informative. Please have a go at answering the questions, and your teacher will be able to go through the answers with you, or I will send you the PowerPoint for you to go through your own answers. Any questions, please do contact me or your teachers. Have a great day, and don't forget to subscribe to the channel.